Now, how is everyone doing today? Okay, so then you should have received a message that said something like that Brady McCary wants to share some files with you on Box. So that's where you'll download your homework, the stuff that you need to print out and do and turn in. Okay, so then all the ones that start with 0, 0. So in the first place, all of those exercises have a barcode on them. That barcode is unique to you. So that's your page, it's not someone else's. The exercises are identical. No one has an easy exercise, and some people have hard exercises. They're all the same. Okay, but the barcode corresponds to you. The due date is next to the barcode. All the ones that start with 0, 0 correspond to lecture 0, 0, and they're all due Wednesday. Even ones at the beginning, odd ones at the end. All the ones that start with 0, 1 correspond to lecture 0, 1, and the even ones are due at the beginning of the Friday 7 days from now lecture, and the odd ones at the end. So as for the ones that start with 0, 0, the ones due Wednesday, there's like 6 pages. Now, don't panic. That seems like a lot, but actually something like the first 4 or something like that are you just need to read them so that you can understand the way the whole grading procedure in the course works. Because it's a little bit complicated. It's a little bit complicated, but if you just read the thing, I hope it'll be pretty straightforward. We'll talk more about it as we get further into the semester. So really, as for the stuff that's due Wednesday, there's just like 2 exercises that actually require some math. Okay, so then now, so I think there's like 6 sheets of paper. What that means, you print out each of the 6, and then there'll be 6 stacks up here. You put this page in that stack, next page in the next stack, next page in the next stack, all the way down the line. So you can't like print them double-sided. Don't staple them together. Different pages, different stacks. Any questions? So if you didn't receive a message about, sharing files on Box or what have you, then something's wrong and you need to get it figured out. Okay. Good. So now, when your stuff is graded, when your homeworks and quizzes and what have you are graded, physical sheets of paper, they won't be physically returned to you. Rather, they'll be scanned and posted on Box in the same place. So the reason for that is that anytime in any of your courses, including this one, you submit something to an instructor and it becomes part of your grade for the course, then that information constitutes a part of your academic record, and it is absolutely forbidden for anyone to share any parts of your academic record with anyone. So like if your mom calls and says, "Hey, how's Timmy doing?" I have to just basically say, "I neither confirm nor deny the existence of anyone named Timmy." Okay, and that's all I can do. Okay, so, and it's the same thing with your medical records, I can't just call up your doctor and say, "Hey, I want the medical records for whoever," because your doctor would just say, "Bye." That's all that, can't do that. All right, but Box is the UTD blessed place where we can actually share files like that. That's what Box is. Okay, any questions before we get to math? All right. Oops. All right. So then, when we left last time, we were talking about that multiplication is repeated addition, and that exponentiation is repeated multiplication. Okay, so we're gonna recapitulate that for just a minute, and then we're gonna get to new things. Okay. So then, in 2 columns. So, left column is that 0 is the additive identity. It's the additive identity because x plus 0 is x for all x. It's called the identity because 0 is neutral with respect to adding. So if you add 1, the result is different than what you began with. If you add 2, the result is different. If you add -8, the result is different. But if you add 0, nothing changes. So 0 is called the additive identity. So blank is the multiplicative identity. Okay, so blank. What we want is we want a number such that multiplying with this number is the same as doing nothing. So that number is 1. So the number 1 is the multiplicative identity. Because x multiply 1 is x for all x. All right. So generally speaking, in this class, we're basically only interested in like 3 arithmetic operations and their inverses. So we're interested in add, multiply, and exponent. We're also interested in their inverses, right? Subtract, divide, and something called nth root. There are other operations to be had in the wide world. So if you had something called, an operation called banana, then you'd need to figure out if there's a banana identity, right? We have something called add, so we want to know about the additive identity. We want to know if there's something called, we have multiply, so we want to know about the multiplicative identity. And if we were talking about the banana operation, we'd want to know if there is a banana identity. That banana-ing with this thing is the same as doing nothing. Okay. 2. Multiply is repeated add. Multiply is repeated add in the following sense. So this is that table of expressions that I wrote last time, and I kind of wrote it in a kind of a cute order to sort of convince you of what goes where and why. So here it is. So 0 times x is 0. 1 multiplied by x is 0 plus x. 2 multiplied by x is 0 plus x plus x. So generally speaking, the pattern is where this digit in the front is a natural number. It's to do it, you take a 0 and that many copies of x and then add them all together. So if this was a 22, you'd take a 0 and 22 copies of x and then add them all together. That's what you do. Okay, any question about this? How many times does x occur over here on this side? Yeah, right. So you're telling me that x occurs 2 times? That's the reason why 2 multiplied by x is sometimes called 2 times x, because over here it occurs 2 times. Okay, it's about counting. Similarly, exponent is repeated multiply. Okay. So, writing that down, so similar to over here, we have x and then caret 0. And understand that usually you would write that as x and then like that. You don't typically write the caret. So what is the answer?
1.
It's 1. And then x caret 1. Usually, you would write that as x to 1, and then even more usually, you wouldn't even write the 1. But at any rate, the answer is 1 multiplied by x. And then x caret 2 is usually written in this way, and is defined as 1 multiply x multiply x. So, that says x, and the exponent is 2. So take a 1 and 2 x's, and multiply it all together. That's what x squared is. And if this was 22, then you'd take a 1 and you'd take 22 x's and you'd multiply them all together. That would be x to exponent 22. So, fine. So any questions about this so far? Now there is one exception that is notable. Well, I don't want to go to the exception yet. So now when we go over this, and because this is not the first time I've taught this class, in history, my history of teaching this, almost every student can immediately say that 0 multiplied by x is 0. And then I say, yes, that's correct. Why is that correct? And then usually students at that point say something like, because Miss Harris told me in like 4th grade or whatever. Okay, fine, but Miss Harris, she's not the authority, she doesn't make the rules. And then this one is even, the response is even less strong. So many students, when they first get here, I ask, well, what is x to exponent 0? Most students can't say 1. They don't know that it's 1. Maybe not most, but a big fraction, probably a third. Then of the students who do know that it's 1, and I ask, okay, why is it 1? Then it's even a less, even a less strong Miss Harris? Why? Why is this 0? Why is that 1?
0 times any number will still be 0. So if you're multiplying 0 times 2, it's essentially like 0 times 0.
Uh-huh.
Still 0.
Okay, now that answer, that's the Miss Harris answer.
Is it?
Yeah, it is. It is that way because Miss Harris said it was that way. Okay? So, you've got to understand what multiplication is. Multiplication is repeated add. It's repeated add. So, here we're saying do an add twice. If this was 22, it would be saying do 22 of them. Here we're saying we're going to do no adds. We're going to do no adds whatsoever. We're going to do no adds. So whatever the answer is, it has to be the element that is neutral with regard to add. It has to be the additive identity, which is what? 0. It's 0 because we're repeatedly doing this, and because we're doing it no times. That's why the answer is 0. That's the reason why. Not because Miss Harris said. Okay, similarly, why is this 1? Right, because this is exponent, which is repeated multiply. It's repeated multiply. And this is saying that we want you to do no multiplications. 0 multiplications. So the answer needs to be the value that is neutral with regard to multiplication. That's the reason why. Good. Now there is one exception to this rule. So for example, how about what's 10 to exponent 0? 1. Okay, so that's good. How about negative 8 to exponent 0? What's that? 1. All right. How about something like pi to exponent 0? What's that? 1. So far so good. We keep taking things and raising them to exponent 0, and we get 1. So things stuff's working as expected. But there is something that I can't write there and have it work. And what won't work? 0. So 0 to exponent 0, like that is not defined. The reason why it's not defined is not beyond our reach. It's a little technical, but not beyond our reach. I'm just going to mention in passing that it's not defined for reasons that are entirely analogous to the reason why division by 0 is undefined. So you can't divide by 0. For a similar reason, you can't do 0 to exponent 0. Any question about this? All right. But you can do anything else at all to exponent 0, and the answer is 1. All right. So what I want you to observe is that we kind of have like a sequence of operations. We have add, you know, that's a thing, and we're just saying that we know what add is. You know, Miss Harris. We're going to go with Miss Harris on the add thing. Okay. Then if you do add over and over, if you repeatedly do that, then the thing that you end up with is multiply. Now, if you take multiply and you do that over and over again, repeatedly, then what do you get? You get caret. So can you see that there's a, oh, this one has repeated that one, and this one has repeated that one. And then you might ask, hey, what if we do caret over and over again? Is that a thing? And the answer is, yeah, that's a thing, but we don't talk about it in this class. If you want to know its name, its name is called tetration. So you can Google that if you care. But you can do this thing is repeated that thing as far as you want, as far as you care to take it. All right. Good. So here's an example of dealing with this. So evaluate the following. So evaluate something like 2 multiplied by x squared and then raised to exponent 3. And now we're going to do it in a very highly specific way. Okay, by reducing to all multiplies. So that means that it's not permitted that there should be any other operation. Regroup. So reorder and regroup. And then express with exponents. Okay, so you'll see what I mean when we do it. All right, so it says to do it this way, and notably, so some first notes here is that, is this going to be tedious? Oh yes, it's going to be tedious, but we're still going to do it. And are you going to be assigned a question where you have to do it? Yes. Do you have to do it that way on that question? Only if you want credit. Will you have to do it that way for every exercise in the course? No. My goodness. If you had to do it that way for every exercise in the course, then the stuff I asked you to grade would be completely ungradable. You'd have to submit a book. Okay, but you're going to need to do it this way on this exercise. All right. So 2x squared cubed. All right. So it says that the first thing you need to do is you need to get it down to a point to where there's only multiplies. So currently there's multiplies, you can see it right there, and there's also carets. Now, you know, we're taking the convention that superscript on the right means caret, right? So there's a caret, there's a caret. So we need to get it down to multiplies. So the first thing I'll observe is that because we have, you know, thing caret 3, that means that we need to make 3 copies of this and multiply them all together. That'll get rid of the caret 3. All right. Yes?
Why aren't we working in the parentheses first?
That would be fine.
Okay.
That would be just fine. So I take it to mean that you might first express this as 2 multiply x x. Multiply.
Yeah, that's what I was thinking.
That would be just fine. That would be just fine. So now there's a caret, there's a caret, there's a caret, and then to get rid of this caret, x times x, right? All right. So 2 multiply x, and then 2 multiply x, and then 2 multiply x. All right. So now, in order to do what you know, this reorder and regroup thing, notice that there's 3 groups, 1, 2, 3 groups. The groups meaning parentheses. Now, you know, these groups are multiplied together, and then everything that's in the groups is all multiplied together. So really, that's just a long string of multiplications, and I'd really like to be rid of those groups. Is it permissible that I should get rid of the parentheses. Okay? What's the name of the what's the name of the rule that allows us to drop the parentheses? The associative rule, right? Because remember, to associate means to form a group. So you can group and ungroup freely. So you can say, okay, this is 2 multiply x multiply x, multiply 2 multiply x multiply x, multiply 2 multiply x multiply x. So this right here is possible because multiplication is associative. Now you can see in that string of multiplications we've got some 2's and we've got some x's, and they're not all together, they're kind of dispersed. And I'd really like it to be the case that all the 2's are together and all the x's are together. I'd really like to reorder all those things. Is it permissible for us to reorder them?
Yes.
Okay, what's the name of that? Starts with C, the one where you can move stuff around. Commutative. Okay, so we'll move them into convenient places now. So 2 multiply 2 multiply 2, multiply x multiply x, multiply x multiply x, multiply x multiply x. Okay, so now we moved all the stuff together, and really it was our intention to actually group them together. So now they're sort of like informally grouped together. We got the 2's all together and the x's all together, but now let's make it official. Let's put some parentheses. So this right here was because multiplication is commutative. Now we'd like to put parentheses around the 2's and parentheses around the x's. Is that permitted?
Yes.
Yes. Why?
Associative.
Because it's associative. So 2 multiply 2 multiply 2, multiply x multiply x multiply x, multiply x multiply x multiply x. 1, 2, 3. Okay, good. And now finally we're in a place where we can say, oh, now I recognize what it is. Specifically, that's arithmetic I can do in my head. What is 2 times 2 times 2? It's 8. And then, here we have 6 x's all multiplied together. Wouldn't it be great if we had some kind of more compact way to write that? Sure would. X to 6. Okay, good. Any question about it? So that's what I mean, if it wasn't clear what I was saying before, that caret, exponent, is repeated multiply. That's what it is. And the reason why you want to be able to say it is because isn't this shorter way to write that? Yeah, of course it is. Human beings want to take the most economical route to the end. Now, by the end of next week, if you were faced with such an exercise, you would just more or less immediately go from here to here. Okay? But the question would just say, take this and simplify it. It doesn't say, take this and simplify it by doing all of these things. So you see the difference? Okay, good. Any question about this? All right. So, another rule. So we'll call this Remark Distribution. So let x and y be in the reals, which is just to say, suppose we have any old numbers x and y, and we've got n, which is in the naturals. So x and y can be any numbers, but n has to be a natural. So what does that mean? Can't be just any number.
Non-negative integer.
A non-negative integer, right? Which is to say, it can't have a fractional part, and it can't be negative, which means stuff 0, 1, 2, 3, 4, blah, blah, blah. All right, so we've got stuff. So again, I'm going to do 2 columns, left and right. Okay, so on the left is something that you know. Okay, and on the right is going to be something that it's less likely that you know. All right, so on the left, we have the following. So if you do n multiplied by x plus y, like this. Now, last time, when we were talking about the properties of the reals, we were saying, you know, that the reals have the property that there's such a thing called add, there's such a thing called multiply, and add and multiply play together nicely with this thing called distribution. Okay, so then I can just quote that and just say that that here's the answer. It's that, you know, x, you get an n, y, you get an n. So the result is nx plus ny. So that's just the definition of what the reals are. Now, I want to convince you that this is reasonable in a different way. So observe. We're going to consider the case where n is 3. So we want to look, you know, what will that look like? Okay, so that would look like this: 3 multiplied by x plus y. And now I'm going to ignore distribution and pretend that I don't know what that is. Okay, I don't know what distribution is. Rather, I'm going to just use the definition of multiplication by natural. So I can see that I'm multiplying something by 3. And according to the rules on the previous page, what does that mean I'm supposed to do? Yeah, I need to make 3 copies of whatever it is I'm covering up. Make 3 copies of it, and then add them all together, because multiplication is repeated add. First copy, second copy, third copy. So I made the 3 copies, and then because multiplication is repeated add, the thing that we're doing is we're adding them. Now what I'm going to do is exactly the same sequence of operations that I did on the previous page. I'm going to say, hey, look, it's all adds. So I'm going to drop the parentheses. Is that permitted? Yes, because add is associative. And then I'll say, hey, look, there's really just 2 kinds of things. There's x's and y's, but they're all mixed up. So I'm going to sort them into an order that I like. Is it possible for me to sort them into an order that I like?
Yes.
Yes, because addition is commutative. And then I'll say, it's kind of like informally that the x's have made a group and the y's have made a group. I'm going to make it official and put them in some parentheses, which is permitted because addition is associative. So now I'm going to do that all very quickly. So bye-bye parentheses. Reorder them like I want. Haha, I had an intention, and my intention was to make them a group. And now, my hand's starting to get a cramp, so wouldn't it be nice if there was some shorter way to write x plus x plus x? Is there some shorter way? There is? What is it?
3x.
3x. 3 multiply x plus 3 multiply y, which is of course what you would get if you just now suddenly remembered, oh yeah, distribution of multiply over add is a thing. Right? So can you see it? Okay. So here what I want you to see is that what this is saying is that multiply distributes over add. You know, we already said that. So now we're going to do something in the right column. And it's going to be a completely analogous thing that we're going to do. But instead of using the operations add and multiply, we're going to use the operations multiply and exponent. All right? So now what we're considering is this. Is x multiply y and then exponent n. Like this. But notice that that's a caret, right? That's x multiply y and then all of that caret n. And the question is, you know, what do I write here? So I'm going to leave that as a blank for a moment, and let's come to the answer. Okay, so you may know it already, but we're going to arrive at the answer by observing, again, the case when n is 3. So, all right, I'll say, how about, so x multiply y, and then exponent 3. And so what I'm working under the assumption that I don't know what goes there. But I do know what exponent 3 means. It means that whatever it is that I have there, what am I supposed to do with it? I need, well, yes, that's what that's called, but using the rule, right? Just like over here, over here I said, well, what am I supposed to do three thing? You make 3 copies of thing, and then add them all together. So here, what are we going to do?
Make 3 copies and multiply them together.
Right, we make 3 copies of that thing. First copy, second copy, third copy. And because exponent is repeated multiply, we take those 3 things and we multiply them all together. So that's what it is according to the definition. So now I'm going to do exactly the same things. This is going to be the 3rd time I've done it. I'm going to say, well, I'm going to drop the parentheses. Why is that permitted? Because multiplication is associative. Then I'm going to say, hey, look, it's x. There's only 2 kinds of things, x's and y's, but they're all mixed up. I want to sort them into order. Is that permitted? Yes, because multiplication is commutative. And then I'll say, haha, it's kind of like I made informal groups of x's and y's, but now I'm going to make it official and put parentheses around them. Is that permitted? Yes, because multiplication is associative. So you can say, okay, well, x, y, x, y, x, y, x, 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 y, 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 a group, x, 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 a group, y, y, y. And then, wouldn't it be convenient if there was some shorter way to write x, x, x? Oh, there is, right? So then this is x cubed multiplied by y cubed. So, that being the case, what is the answer? Right. X to n multiply y to n. Not for some arcane reason that, someone just decided back in the day that this is how we're going to do it. No, it's because that's the only way that structurally it works. This is how it works. This is about counting. This is saying that if you have xy to exponent 3, then you're making a bunch of copies, sorting things into order, making groups, and saying that, oh yeah, at the end of that there will be 3 of those x's and they'll all be multiplied. And if you do the same thing here, if this n is like 1,000,000, there'd be a whole bunch of x's to write. Okay? But in the end, there'd be 1,000,000 of them. Okay. So here, in the left column, we said that multiplication distributes over addition. What are we going to say here?
Caret distributes over multiplication.
Yes, caret distributes over multiplication. So now, we have 3 operations on the page, and they form a sequence. The sequence is, we have add. Repeated add is what? Multiply. And repeated multiply is exponent, caret. Now, what I want you to observe is that we have a distribution rule for this pair. There's a distribution rule for that pair. It's right there. We have a distribution rule for this pair. It's right there. There is no distribution rule for these 2. There isn't one. Now, let me be clear about to try and get the gravity of what I'm saying. So here's a statistical fact, assuming that this class is not somehow anomalous in all the history of college algebra. 10% of you, even on the final exam, are going to be making the mistake of trying to distribute that one over that one. Through all 16 weeks, you're going to do it every week, up to and including the final exam. It is an exceedingly common error. Okay? They can't. The distribution won't work. This works. That works. That doesn't work. All right. So let's see. So here's a typical example. So a typical example is something like this. Evaluate this. So x plus 5 squared. All right. So I'm going to do this in two ways, the wrong way and the right way. So if you're going to copy me doing it the wrong way, then please carefully note in big bold print somewhere that it's wrong. Okay. So first way is the wrong way. This is the most common wrong answer. For a student to do the following, to say something like, okay, x plus 5 all squared. That would be x squared plus 5 squared. But usually the student won't even write 5 squared. They'll just immediately write x squared plus 25. So this is wrong. And if you think that that's right, then this should be a very big wake-up call to you. Okay? So this is not. This is wrong. It's incorrect. Now let's analyze the reason why it's incorrect. The reason why it's incorrect. In my view, it has part of the reason why so many students fall into this trap is that we do have distributive-like things all over the place. That and that. But also we have the convention that we don't, in some sense, officially write the name of that. What is the name of superscript 2? What's its name? It's caret, right? That's its actual name. That's its name. So what this is doing, if you think that this is right, then here's what's happening. You're saying that x plus 5 caret 2. Now, what operations are there? There's add and caret. Now, is there a distributive law for add and caret? No, there isn't one. If there was one, there isn't. But if there was, it would be this. It would be saying that, well, it's got to be x caret 2 plus 5 caret 2. If there was a distributive law, and that's what that is. But this is just not right. It's wrong. Okay. Nevertheless, this is the most common error. Okay, so now let's do it correctly. So the correct way to do it is to look at this and say, okay, I see two operations. I see add and I see exponent. Is there a distribution law for that? No, there isn't. So I can't use that nice compact way of dealing with it. I've got to do it some other way. So the way that you do it is you say, okay, well, I've got thing and then squared. That means make two copies of thing and multiply them together. That's what it means. So x plus 5 multiply x plus 5. Now, we want to be able to do this. And the way that we're going to do it is we're going to consider one of these to be like sort of the parentheses are like a box. And you can, we can see inside the box that inside the box is an x plus 5 for that one, and inside the box is an x plus 5 for that one. But what we're going to go with is we're going to say we're only going to peek inside one of the boxes. So like maybe we can peek inside that one, but what's in here is anybody's guess. I have no idea. And what we're going to do is we're going to distribute whatever this is to the things inside here, right? Because that's a multiplication, and we can do that distribution. So we're going to say that this distributes to that and to that. Okay? So the result is x plus 5 multiply x plus x plus 5 multiply 5. Okay. Now, we can do more distributions, which is to say that, oh, look, here this x can distribute this way, so you get an x and you get an x, and you get a 5 and you get a 5. All right, so we'll do that. So, doing that, x times x, what's the most compact way to write x times x? X squared, so we'll write that. And then plus 5x. And then plus, now for this one, another 5x, so 5x. And then 5 times 5, that's 25. And now simplifying things a little bit. So 5x, you know, that's like 5 apple. And then we have another one. So altogether, how many x's? 10. So plus 10 x's, and then plus 25. This is the correct answer. So here's what I want you to see, is that this one right here is the most common incorrect answer. The most common incorrect answer, and in the end, what it is, it's a failure to understand that exponent does not distribute over add. Here is the correct answer. Notice that concerning the incorrect answer and the correct one, they both have an x squared and they both have a 25. But the correct answer has this 10x. And the 10x is in some sense a measure for just how much the exponent operator does not distribute over add. How much does it not do it? That much. Okay. Any question about this? All right. We need a little bit of terminology. So, if you have an expression that looks like this, so given something like this, some nice expression like 13 multiplied by x squared y plus 14 w cubed minus 8 z, say. So something like that. Then, the things that are separated by pluses and minuses. Pluses and minuses. So, so these things. So this one, that one, and that one. So if you sort of close your eyes and say, oh yeah, you know, this thing and that thing and that thing, they're all sort of separated by an add or a subtract. These things are called terms. Parts of an expression that are separated by pluses and minuses. Now, within terms, you can see that, oh yeah, there's little bits that are separated by multiplies and divides, you know, because I could have made one of them a divide. So these individual items things that are separated by multiplies and divides, those are called factors. So, for example, you can see that here's a term. How many factors does it have? 2 factors. They are 14 and w cubed. Right? Here's this whole thing is a term. How many factors? 3. Okay, good. Now, this thing that we did on the previous page, this thing right here, there's a much shorter way to do it that we're gonna write down right now, a nice formula that you should take the time to memorize. In fact, you've probably already memorized it and know it by name. Okay? But before we do that, I have to say the following thing. So if you have an expression with one term, the name for that, the name that we'll say out loud, that's called a monomial. So the prefix mon literally just means one, and nom means name. So in some sense, monomial exactly translates as one thing. If you have an expression with two terms, then what's the name for such a thing? Binomial. If you have an expression with three terms, what's the name for such a thing? Trinomial. Now, these prefixes, if I remember correctly, I think come from Greek or whatever, and then you could go on and say quadrinomial and quintinomial or whatever, but I've never heard that ever in my life, except for people saying that we don't say that. So monomial, binomial, and trinomial, that's about where it ends. So you need to know those names and know what they mean. So here we have something. Its name is blank, and I'll leave it there. The blank, we'll fill that in. It is the product of binomials. So what if we have something that looks like a plus b multiplied by c plus d? So now, in this expression, do you observe that concerning the whole expression, there's one term, just the one. And that from that point of view, there are two factors. The one on the left, the one on the right. And then within each factor, what kind of thing is that? A binomial, right? Because there's two terms. And what kind of thing is that one? A binomial. So can you can you see that this is the product of binomials? Okay. So now, the only way to do it is exactly the way that we did it on the previous page. So now I'm going to do it very, very rapidly. I'm going to say, okay, I'm going to peek inside the box and distribute this one to that one. So you get that. So this will be a plus b times c plus a plus b times d. Now I'm going to distribute the other way. You get a c, you get a c, you get a d, you get a d. So we have AC plus BC plus AD plus BD. So do you observe that now in this expression, how many terms are there? 4 terms, and every term has 2 factors. Okay. Now, for reasons that aren't entirely clear yet, I'm going to take the 2 middle terms and I'm going to put them in the other order, which is permissible because addition commutes. AC plus AD plus BC plus BD, which is to say this one here, that one there. Now, in this binomial, there's A and then there's B. Now, as written, if I had to say which one is first, A or B, what would you say? A is written first, right? And then how about in that one? C? So A and C are the first ones? So here's AC, something that has A and C in it. Let's label this F, because that one resulted from taking the first ones. Now, taking this thing as a whole, A, B, C, D in that order, concerning A, B, C, and D, which pair of terms would you say are the ones on the outsides? A and D? Hey, look, there they are. Let's label it O for outside. And then concerning these, so concerning these 4, which 2 terms would you say are the ones on the inside? B and C? Oh, here they are. How about we label this one I? And then concerning this one, which term would you say is written last?
D.
And for that one?
D.
And there it is. So let's label this one L. So of course, what's the name of this thing? FOIL, right? So all that FOIL is is it's 3 distributions, a commutation, and a few associations and deassociations and reassociations, and that's what FOIL is. Okay, so let's do one quick FOIL, and then we're done for the day. So for example, x plus 3 multiplied by x plus 5, say. Do you observe that this is the product of binomials? Yes. Therefore, FOIL will work. There should be exactly 4 terms. We're going to write them all down. So what's the f term? So it would be xx, right? And what's the most convenient way to write xx? X squared. Plus. And then the o terms? X and 5. So we'll write that as 5x. The I term? 3 and x, so I'll write that as 3x. And then the L term? 15. And then now, oh look, I can do a little bit of simplification. X squared plus 8x plus 15. The shortest way to go about that. All right, have a nice weekend.